When we look into the deepest parts of the ocean, the abyssal zones, it's not just dark. It feels completely alien.
Utterly.
And it seems like every time we send a submersible down, we find something that just redefines what we thought life could be.
Right.
The latest example of that has to be the Advhena magnifica. I mean, it's a creature that looks like it walked right out of a 1980s sci-fi movie, but it's literally made of glass.
It is the perfect subject for a deep dive. Our mission today is to really get into the fascinating biology and just how significant this brand new genus and species is.
Okay, so let's start with the identity. Everyone calls it the ET sponge.
They do.
Does the official name Advhena magnifica hint at that too?
It actually does. It's Latin for magnificent alien.
Oh, perfect.
It just earned that ET nickname instantly. If you look at it, it has this long, thin stalk and then a rounded body with two really big, obvious holes, the oscules.
The oscules, right.
And when the researchers first saw that video feed, they couldn't unsee the eyes of the movie Alien.
That's an amazing image. So where was this magnificent alien actually found?
It was first spotted during one of the NOAA Okeanos explorer expeditions. This was back in 2016.
Okay, so a few years ago.
Exactly. The collection site was the Pigafetta, which is basically a huge, flat-topped underwater volcano east of the Mariana Trench.
So we're talking about extreme depths here.
Oh, extreme. Over 2,000 meters down. It was only formally described in 2020, and it immediately landed a spot on the World Register of Marine Species top 10 list.
So it looks like an alien, we know that. But the construction, the fact that it's a glass sponge, that's the real marvel here, isn't it? A skeleton made of fused glass.
Correct. But here's where it gets really interesting. The truly wild part is its internal system. Unlike us with our separate cells, the tissue of these glass sponges is largely syncytial.
Syncytial, what does that mean exactly?
Think of it like a biological cobweb. It's not a collection of individual cells. It's one continuous mass of cytoplasm that shares multiple nuclei all floating within it.
A biological cobweb. So this unique structure.
Yeah.
What does it do for the sponge?
It's all about communication. That continuity allows it to conduct electrical signals across its entire body incredibly fast.
It basically has a nervous system, but without any nerves.
That's a great way to put it. Yeah. And it's absolutely key to its survival.
So it's not just sitting there. It's actively responding to its environment.
It's optimizing. It allows for really instantaneous internal system analysis. If the sponge senses too much sediment in the water, maybe from a tremor, that electrical impulse instantly tells the whole organism to shut down its feeding current. It protects its fragile glass structure from getting clogged.
Wow. That kind of instant system analysis. That is something so many businesses are trying to achieve right now.
It really is. And, speaking of advanced system analysis, this is actually a great moment to mention our sponsor.
Of course.
If you are wrestling with complexity in your own business, maybe trying to figure out where new AI agents could have the biggest impact for automation, you should check out Embersilk. They specialize in AI integration and custom software development. You can find out more at embersilk.com.
Okay, so we've got this creature with this incredible internal system. But what does it mean for the wider ocean environment? What's its role?
A huge one. It's what we call an ecosystem engineer.
Right, filter feeders.
Exactly. They are powerful filter feeders. And because they're so deep, they play this really crucial role in processing nitrogen and carbon in an ecosystem we frankly know very little about.
And if we connect that to the bigger picture, discovering a completely new genus must hint at massive potential for us for human health.
Absolutely. Think about it. These sponges can't move, so to defend themselves, they produce novel chemical compounds.
A kind of chemical warfare.
Pretty much. And the extreme pressure and low nutrient environment forces them to evolve some really unique defenses. The compounds in Advhena magnifica could be incredibly promising for bioprospecting.
Finding new medicines.
Finding new medicines for human diseases. The deep ocean is just this incredible untapped library of potential solutions.
That's so hopeful.
It is. And here's a final thought for you to take away.
Okay.
We know that other deep-sea glass sponges can live for centuries. Some estimates go up to, 15,000 years?
15,000.
15,000 years. So if Advhena magnifica shares a similar longevity, just imagine what secrets of resilience, of survival, are held within that glass architecture, just waiting for us to understand and maybe even apply.
That is a spectacular image to end on. The deep ocean's glass architecture. You enjoyed this deep dive? Please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.